Hello everyone, this is Maurizio, editor-in-chief of Embedded.com, and I have here today at Embedded World showing in Nuremberg, and I have the pleasure to be here at the booth of ARM, and I have the pleasure to be here with a great speaker, Suraji Gajendra, Vice President of Automotive Products and Software Solutions at ARM. Hi Suraji, thank you for your time. How's it going?
Hi Maurizio, very well. Thank you so much for having me in this one.
Thank you so much for your time, for coming on at my show. So let's start with my first question. So I have prepared a couple of topics to share with you.
Yeah.
So what's new from ARM at Embedded World?
What's new? Yeah, a lot of things. As you can see, the show is buzzing with a lot of technology. ARM technology specifically. Mm-hmm. But I think the biggest news that we actually announced yesterday is basically the Kleidi AI.
Okay.
Specifically bringing it into automotive, right? So Kleidi is the essential AI software infrastructure, primarily the libraries that can be used by software developers to optimize and improve performance of their applications on ARM CPU and ARM technology. So we announced that Kleidi has been there in our other markets like clients and stuff like that, but now we are bringing that into automotive primarily to enable the developers to sort of build good Gen AI applications that are more targeted to automotive. So that's, from an automotive perspective, that's the big news this year.
Good. So let's stay on automotive market, automotive application. So my first question is, let's understand how do you see the adoption timeline for chiplets in the automotive industry? This is a big topic.
It is a big topic.
Yeah.
And chiplets.
It's always a big topic. No, sorry, that's okay. So which are the biggest challenges in this regard for a widespread implementation? And the next topic that I would like to share with you, and you may elaborate a bit, is standardization. Is also critical. So chiplets can include CPU, GPU, and so on.
Right.
So the important is standardize to increase the adoption. So tell me your comment about chiplets.
Right, no, great questions. I think, look, I mean, end of the day, the automotive industry is evolving very, very rapidly. There is a lot of new features that are getting pushed into the car, be it autonomous drive or ADAS applications, or even just the in-vehicle applications, new driver monitoring, passenger monitoring, and stuff like that. Now, all of this actually needs a lot more compute in the car. Okay.
Yep.
B, the compute architecture has to be very scalable. So what I mean by scalability is, see, if I'm an OEM, I would want to make sure that my software application that I'm actually enabling, be it the Gen AI software applications, they are enabled across the different models of my car, right? So, I mean, because most of the AI applications are becoming table stakes, you will have to enable that on, some amount of that in the lower end cars and, a lot more in the higher end cars. So what they would actually need is they need a consistent hardware architecture from, say, IVI to ADAS and autonomous driving. So when you think about it that way, the scalable hardware architecture is very, very critical. And then, the only way today that you can actually enable the scalable hardware architecture from low end all the way to high end is chiplets. So chiplets is going to play a very, very important role in the automotive compute space. And but there are, again, it's easy said than done, right? There are a lot of challenges for us to work together as an ecosystem to enable. You can actually, I mean, again, when people talk about chiplets, they talk about mix and match of chiplets.
Yeah.
And when you enable, mix and match of chiplets, you will have to have some rules and regulations or standardized way of mixing and matching those chiplets. So, it's one thing where you basically have just the interconnect standardization. UCIe is an industry standard that is basically being pushed to have die-to-die communication. But the need for standardization grows much beyond just the UCIe interconnect. You got to think about how power management happens across all of those different chiplets. You got to think about how debug happens across all of those chiplets. You got to think about how security, how secure boot happens across all of those chiplets. So it's important for us as, the people who are actually putting the foundations in to think about all of those aspects and bring standardization on how two chiplets can actually talk to each other. Like for example, if you have a chiplet-based system and a car deployed with the chiplet-based system, and if and if there is a problem, you will have to have a more standard way of debugging the problem. You will have to figure out a way to, navigate through all of the chiplet architectures to basically say, here is the problem, right? So standardization is key, especially around some of these foundational elements. There's definitely plenty of options for differentiation, but in the core elements of compute architecture, we will have to ensure that there is standardization.
This is great. Thanks for sharing. So another topic that I would like to share with you, talking about automotive, talking about mobility, is software-defined vehicles, or SDV, as we can find in different blogs. So these are becoming central, important for the future of mobility. So how does ARM's technology stack contribute to enabling SDV, software-defined vehicles? So, and how do you see also the role of AI evolving in software-defined vehicle when it comes with the features about real-time decision-making, for example, security as well?
Absolutely. So let's start from right at the top, right? So what is software-defined vehicle? So from a software-defined vehicle perspective, the way we all understand is the ability to keep the car updated with new applications and features even after it rolls out of the dealership, right? So that is basically the definition of what software-defined device is. So it needs to be upgradable, it needs to be updatable, and new capabilities needs to be pushed into it. Now again, just like the chiplet stuff, it is necessary. It is absolutely foundational for the industry to come together and enable this sort of evolution. But at the same time, it's challenging, right? To start with, there needs to be a robust cloud-to-car software infrastructure that needs to be built that can then ensure that any software that gets developed in the cloud gets deployed onto the car very seamlessly. We've been talking about it for the last 3-4 years now, but again, there is still a long way to go for us to standardize and ensure that there is a robust infrastructure, right? Because again, from a consumer standpoint, they're expecting the car to just behave like their phone, right? They want to be able to install new apps, they want to be able to unlock new experiences and stuff like that. So now, the way we look at it at ARM is, it's not just a hardware play, it's a full stack play, okay? It is a full stack problem that we need to address. So, and when I say full stack, it's not just vehicle level solution stack, it's a vehicle level solution stack and the cloud to car infrastructure, right? So ARM has been in the forefront driving a lot of standardization. So we launched a program called SOFI along with our key partners back in September 2021. The foundation purpose of SOFI, one has been to standardize the vehicle level non-differentiating software. So all ARM-based hardware can be brought up in the same way, debugged in the same way and all of that. But more importantly, enable that cloud-native environment for software developers. So SOFI has been now, we started off with 6 partners, and now SOFI is 145 members, right? And I am the global chairperson for the governing body. So good. So it's been, it's like ARM is completely vested in trying to ensure that it is a cloud-to-car strategy, and every angle of this whole ecosystem is actually used to the fullest.
Great, this is great. So, and when we are talking about software, software is playing even more a great role in vehicle functionality. Yeah. So what's your thoughts in terms of security and over-the-air update strategies to ensure resilience in software-defined vehicles?
Yes. So great question, Maurizio. I think, look, yes, as I just said in the previous answer, although people expect the car to be just like their phone, but the only difference in a car is if you have a faulty software, then it's a question of life and death, right? So you got to be, safety and security are foundational for automotive. You cannot, compromise on safety and security.
Absolutely.
Now, when you think about safety and security, I'll give you another example, right? Now, there are applications that would need, for example, there is an application, I will not tell which car I'm driving, but the car vendor or the OEM sent me a notification a few months ago saying, hey, and I live in London, So hey, this parking app that you normally use, you can actually install the parking app in the console, okay? You don't have to carry your phone. So a car will, based on the location, will exactly know where is it parked, what is the parking code, and then it will pay for itself. Okay, now it's great, right? Then I don't have to sort of look around for what is the parking code. The car exactly knows, it will pay for itself. But the angle there from a security perspective is you're feeding in your credit card information. Now, is that secure, right? Is it secure enough for you to go? By the way, I have not been able to convince my wife to put my credit card information in the car. That's a different question, but there's still the security vulnerability that we got to think about, right? So, I mean, it's essential that we build in a lot more security in the system, in the hardware and in the software stack. So, you know, the consumers can be rest assured that there is no security compromise, right? Or another critical use case is, you know, you load a new, say, a user experience application onto your car, and you're driving 70, 80 miles per hour on a freeway, and then suddenly realize that there is, you know, you don't want that new application that is installed to muck around with, you know, basic functions of the car. So there is, you know, so from a technology stack perspective, there needs to be proper realms. ARM has been pushing, for example, the ARM confidential compute architecture that we've announced, you know, to drive a much more end-to-end security in the solution stack, and not just from a hardware perspective. So it is a difficult problem, but I believe, you know, together, ARM and our ecosystem, we will make sure that, you know, end of the day, when we are at that stage, when we are like truly in a software-defined vehicle era, things will be secure.
Thank you. So, Suraj, just in conclusion, my last comment, my last question. So let's do a sort of recap, takeaways in terms of what could be the biggest obstacles in scaling autonomous solutions, how ARM is also addressing these challenges, but in particular, I guess that no single company can solve a lot of obstacles, complexities that we have. So what specific collaboration or industry initiative do you think are most important, most critical to address, to accelerating the progress in this field?
Yeah, the single most biggest challenge, I would say, again, you know, the two major aspects that I mentioned already. One is creating that robust software flexibility and software, you know, infrastructure needed for cloud to car. Then once you have that, then you're sort of pretty, you know, well placed to go expand the horizon in terms of software ecosystem for applications just like the phone. Again, you have so many different application developers pushing in new experiences into the phone. You will have a similar sort of infrastructure or ecosystem for automotive. But the biggest challenge is to enable that entire software infrastructure. For that, for example, what ARM is doing is we are ensuring that there are virtual platforms for our hardware built in the cloud. Okay. So there is a much more seamless, you know, there is much more parity between the software that gets developed in the cloud and software, you know, that gets deployed. So there is the hardware environment is as close to being same, right? So that's one thing. The other biggest challenge, of course, is the hardware scalability that I said. So we talk about three things. I keep talking to my team about three things. One is hardware scalability is important, consistent hardware architecture. You know, the chiplets come in play there. So it's that's one thing. Second is enable a flexible software ecosystem and a robust cloud to car infrastructure. The third one, we call it as ISA parity. Instruction set parity between the cloud and the car, and that's what we are driving. We have ARM in the cloud and now ARM in the car. Once you have these foundationals, I am, again, with everything else that's going on in Gen AI world, I am very sure that we're going to see some applications that we've never even dreamed of right now.
Thank you so much. Thanks a lot for your time. I wish you a good show, a good day at Embedded World.
Thank you, Maurizio. Thank you. Thanks a lot. Bye.
Thank you so much. Stay tuned. Thank you.